Welcome to Tejamay YouTube channel. I have already made two videos on solving the numericals on the chapter which one is that electric potential and capacitance. Especially I have solved the numericals and capacitance in the last two previous videos. Okay, in this video I'm going to solve two more numericals which were appeared in previous year question papers. Okay, the question is like this: the plates of a parallel plate capacitor have an area of 100 centimeters square each and are separated by 3 millimeter. The capacitor is charged by connecting it to 400 volt supply. So calculate, in the first one is energy stored, okay, in the capacitor. Then secondly you have to calculate if dielectric constant, okay, if dielectric constant 2.5 is introduced between the plates of the capacitor, then what will be the new energy stored in the capacitor, and also change in energy stored. Okay, so first let me write the data given here is, okay, so they have considered the parallel plate capacitor. That capacitor looks like this. Okay, there will be positive charge stored here and equal number of negative charges will be stored here. Okay, and the area of each plate, okay, that is given. A is equal to, how much is that, 100 centimeter square, means into 10 to the power minus 4 meter square. Centi means 10 to the power minus 2, square is there, so you will get 10 to the power minus 4. Okay, so one thing is that. Second thing, they have given the separation between the plates, that is 3 centimeter. Let me consider that is small d. Small d is equal to 3 into 10 to the power minus 3 meter, because they have given millimeters. Millimeter is nothing but 10 to the power minus 3 meter. Now this capacitor is connected to 400 volt supply. So this one is connected to a battery of 400 volt potential difference. Okay, now we need to find out the energy stored. We have the formula for energy stored in a capacitor. So that is U is equal to half CV square. Okay, let me make use of this. Actually there are three different formulae for this. You can make use of any one of them by looking like by taking the consideration of the data. So here of C, what is the capacitance of parallel plate capacitor? So if there is no dielectric medium, formula will be epsilon naught A divided by D. In the first case there is no dielectric medium, so we will write like this, into V square. Now let me substitute the data. U is equal to half into epsilon naught value is how much, 8.85 into 10 to the power minus 12 into area of the plate is given. How much is that? 100 into 10 to the power minus 4 meter square divided by small d value 3 millimeter, 10 to the power minus 3 into 3 into V square, 400. Okay, voltage is given 400 square, V square. Now if we solve this particular data, we will get 23.608 into 10 to the power minus 7 energy, so it will be in joules. Okay, next we have to calculate the second case where the dielectric medium of dielectric constant 2.5 is introduced between the plates. Okay, then what will be the energy stored in this case? So here, dear students, between the plates of the capacitor there will be a dielectric medium placed. Okay, then what happens? The capacitance of the capacitor increases by k times, means capacitance value will become, let me write here, C is equal to epsilon naught A divided by D into K. It increases by K. So you will have to multiply by K to your capacitance value. So if I do so, here I will get into K. Okay, so we will directly write that U is equal to half CV square. This is in presence of medium. You will get half epsilon naught A divided by T into K into V square. So U is equal to, we have already calculated the value of epsilon naught A by D into V square, that is this much. Okay, we can directly substitute that. So you can write like this. So energy stored in the presence of medium is Um. This is in the absence of, what is that particular medium. Now I can write U naught into K, because remaining this particular value is called U, epsilon naught A by D, that we have already calculated. Okay, now if I substitute the value here, 23.608 into 10 to the power minus 7 into K value is given, that is 2.5. Let us multiply that. So you will get the value of energy stored in the capacitor in the presence of the medium, dielectric medium. Then you will get 59.02 into 10 to the power minus 7 joules. Okay, so you can substitute the value of epsilon naught A by D and K as well as V and solve. Otherwise we can directly multiply it by K, so that you will get this. Now in the absence of the medium, the energy stored was this much. In the presence of the medium, the energy stored is this much. Okay, now what is the change in this particular energy? That is the third case that we need to calculate. Now change in U is equal to Um minus U naught. You can check here, dear students. When there is dielectric medium, energy stored in the capacitor is more. When there is no dielectric medium, energy stored in the capacitor is less. Okay, you might have already studied about the capacitors in detail in the theory concepts. Okay, so that you are going to apply here. Okay, you can analyze that particular thing here. So Um is, how much is that? 59.02 into 10 to the power minus 7 joules minus, what about this one? U naught 23.60 into 10 to the power minus 7 joules. So you can solve this. You will get somewhere around 35.412 into 10 to the power minus 7 joules. This will be the extra energy that will be stored in the capacitor because of the presence of the dielectric medium. Okay, this is all about this particular video, dear students. You can pause the video and write down the notes. Okay, so this was the question asked in the year July 2018. Now we'll move on to the next question. Okay, dear students, let us take the next one. Here we have the question like this. A 4 microfarad capacitor is charged by a 200 volt supply. It is then disconnected from the supply and is connected to another uncharged 4 microfarad capacitor in parallel. Okay, so how much electrostatic energy of the first capacitor is lost? Very simple concept this one is. So here we will be having a capacitor, okay, so whose value is 4 microfarad. Okay, let me explain the concept here. So first, this one is charged by using a battery of 200 supply, so 200 volt power supply. Okay, so this will get a charge. So let me consider this is Q1 and that is equal to C1 into V1. Okay, then in the second case, what they will do, the same Q1 charged capacitor is connected in parallel with the another capacitor whose value is 2 microfarad. Okay, so then there will be a distribution of charges here. Okay, so 2 microfarad capacitor is connected in parallel. So in this case, what happens, there will be distribution of charges. Few charges will come to this particular capacitor also. Okay, now what you want to calculate here, there is energy stored in E1, that is written, we can calculate. Then because of the connection of this parallel plate capacitor in parallel with this capacitor, then it will lose some charges. If it is losing some charges, means its energy also decreases. How much energy does it lost? Okay, the energy lost by E1 or the capacitor C1 will be equal to energy gained by C2. Okay, so by keeping that in mind, we can calculate E2 also. Then if we subtract E1 by E2, we will get the change in energy. Okay, let us solve it now. Okay, dear students, let me write the data. So here C1 is 4 microfarad and it is connected to a power supply of 200 volt. Okay, so because of that it will get some energy, and then it is connected to another capacitor C2 of capacitance 2 microfarad. Then what will be the energy lost by first one, that is given by E1 minus E2. Okay, now let me write here the capacitor C1 which is connected to the battery V is equal to, how much is that, 200 volt. Okay, now C1 is charged to Q1. This side it is charged, and same negative charges will be stored this side also. Okay, now if I calculate E1, that E1 is calculated by half CV square, half C1 V square. So E1 is equal to 1 divided by 2. C1 is, how much is that, 4 microfarad into V square is 200 volts square. Now here you can cancel 2 2s are 4, so we will get E1 is equal to 2 into 10 to the power minus 4 into, here 200 square is there, that is 40,000. Okay, now if you multiply this, you will get 8 into 10 to the power minus 2. Okay, here it is 6. Now it's correct, joules. Now this is the energy stored in the capacitor when the capacitor is connected to 200 volt, but now this capacitor is connected in parallel with the second capacitor. Let me write that. So here you can consider the capacitor C1 is connected with C2. So some of the charges will come back to C2 also. Okay, now the potential difference between the capacitors will be same here. Why? Because the capacitors are connected in parallel, potential is same. Okay, now the potential across the capacitor is calculated by Q is equal to, we have already studied this, Q is equal to CV. So V is equal to total charge by capacitance. So let me consider the total charge divided by total capacitance. This is the formula that you can make use to find the potential difference between the capacitors in this particular case. Okay, now here the total charge that we have used here is Q1, and that is given by C1 into V1 divided by total capacitance of this combination. Since they are in parallel, you will get C1 plus C2. If it is series, you will get 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3, so on up to 1 by Cn. How many capacitors that you have considered in series case, it depends. Okay, now let me calculate V. That V value is equal to C1 is, how much is that, 4 microfarad into V1 is 200 volt divided by C1 plus C2 is 4 microfarad plus C2 is 2 microfarad that we have connected here, that is 2 microfarad. Okay, let us solve this. So if you solve, you will get 4 2s are 800 into 10 to the power minus 6 divided by 4 plus 2 is 6 into 10 to the power minus 6. So here you will get 10 to the power minus 6 minus 10 to the power minus 6 cancel, so it will be 800 divided by 6 volts. Okay, now what do we need to calculate? Energy stored in C2 we want, so that is calculated by, okay, E2 is equal to half C2 V2 square or V square, next new voltage across the capacitor. Okay, that is equal to half into C2 is 2 into 10 to the power minus 6 into V2 is 800 divided by 6 whole square. Okay, now calculate this. You will get E2 is equal to, here 2 will cancel out, remaining value you will get as 5.33 into 10 to the power minus 2 joules. Okay, finally we need to calculate the change in energy, that will be so which one is greater? E1 is greater, that is 8 into 10 to the power minus 2, here 5.33 into 10 to the power minus 2, so just calculate that, 8 into 10 to the power minus 2, so that is E1 minus E2, 8 into 10 to the power minus 2 minus 5.33 into 10 to the power minus 2 joules. So change in energy is equal to 2.67 into 10 to the power minus 2 joules will get. This will be the energy lost by the first capacitor. Okay, so you can pause the video and write down the notes. Okay, practice well since your examinations are coming soon. Okay, prepare well. So these are the numericals on capacitor that I have solved, and if you have any doubt you can text in the comment section. We'll solve few more particular numericals on this particular topic. Okay, so we'll meet you in the next video. Till then, take care. Bye bye.